Okay, so we are going to now try to enter these points into our calculator. So the first thing we're going to do is hit the stat button. So if you look on the third row, 3 buttons to the right, the very end is stat. So you should be seeing something that looks like my screen up there. Anybody not seeing that? So if I start going too fast, just give me a holler. Just hit the stat. Did you find the stat button?
Oh, yeah.
Okay, so you seeing the same thing I am? Okay, we're gonna hit enter. And mine's already in there from period 1, but I'm gonna do it with you there. So if you have junk in here, you can clear that off if you go up arrow, that's called the menu bar, and then hit clear, enter, and it wipes it clean. And I'm gonna go left arrow, up arrow onto the menu bar, and go clear and enter. Okay, so anybody not have a fresh looking L1 and L2? Okay, so we're going to put for L1 our X values. So we'll go 3, 4, 6, 8. So 3, enter, 4, enter, 6, enter, 8, enter. Okay, then go right arrow, and that's going to put you into the L2 column. And then we're going to put in our Y values in that same order. So 1, enter, 3, 6, 12. 3, 6, 12. Okay, so we have our ordered pairs in there. Okay, so far. Anybody not to here? Don't let it go on without you. Okay, now I'm going to go back to stat. And then we're going to go right arrow to the calculate menu. And we're going to look for a linear regression. And it looks like that's option number 4. So I'm going to down arrow until I'm to there. You with me? I'm going to hit enter. And now, depending, if you have an older calculator, yours may not look like this. Does anybody have something that looks different than what I have on my screen? Perfect. So now we're going to go down to, so it should say that we're picking the X values from L1, the Y values from L2. If not, we could change it and put in the L1 and L2. We're not going to do anything with that frequency list. We're going to go down to store the regression equation. So down arrow to there. You with me? Now we're going to put in Y1. So to do that, we're going to go to the variables menu, VARS, which is just left of the clear button. Okay, find it? So you should be looking at what I see on my screen here. Anybody not to here? Okay, then I'm going to right arrow into Y variables, and we are going to be in functions. So I'm going to go enter, and then I want Y1, so I'm going to hit enter. So what this is going to do in a minute when we calculate it, the calculator will automatically copy that over into Y1 so we don't have to do it. And it'll include all the decimal places of accuracy, which would be a real pain to do otherwise. So I'm going to drop down arrow to the calculate and then hit enter. And it's going to do its work, and pow, there you have it. So it's giving us our slope and y-intercept, because A is the M and the B is the B. So we can write down, and when we write it down, we can just write it to 3 decimal places. We're trying to get used to 3 decimal places because that's going to be the standard next year in AP Calculus, and I want that just to be the default. We'll go to 3. So I'm going to call that 2.136, 2.136x, and then a minus 5.712, minus 5.712. Okay, so there's our line of best fit. That's kind of cool. But our calculator can actually graph this. So we are going to we're going to turn on a stat plot. So you can go second and then y equals, and that's going to take you to the stat plots, and by not looking at the screen. Okay, I'm going to go enter, and then I'm going to enter again. That's going to turn it on. And when we're finished with this, you may want to turn it off because otherwise, it'll really goof up any other graphs that you do down the road. You'll think you're graphing something, and weird things will show up, and you'll be like, my calculator's become possessed, but it's just because your stat plot is still turned on. So now it says that mine is already highlighted the scatter plot, which is what I want. If it wasn't, you could down and right arrow and then just hit enter to turn it on. It's telling us we're getting the X's from L1 and the Y's from L2. That's where we put our stuff. So that's exactly what we want. If it wasn't, we could change those. And mine is going to make these little kind of rectangles when it plots those data points. That's what I like, a little bit easier to see, I think. If it isn't showing that already, just down right over there, hit enter, and that will turn it on, okay? So it's everything that I want. Are we okay? So now what I'm going to do is I'm going to graph this, but I'm going to let the calculator choose the window. What's a good X-min, Y-min, X-min, X-max, Y-min, Y-max to fit all the data in there. And so we can do that by going zoom, and I think we can do either stat or fit. So I'm going to go down to zoom stat and just hit enter. And you can see the data points are those rectangles. Oh, the fun part is watching them pop the balloons. Can you hear them? So you can tell, you kind of get a visual of how good a line of fit we're getting here based on, you know, how close are we and how many of those little bubble things do we actually hit and square on. That make sense? So that looks pretty good, okay? So we're going to talk in a minute about how statisticians can tell how good a fit it is, what's called the R value. But I'm going to go on first and do some other stuff. So suppose now that we have this, this line, this model, so we're using a line to approximate that data. So let's use our model to approximate f of 5. So in our data set, we don't have a data point for x equals 5. But you can see that our smallest x value is 3, and our largest x value is 8. So 5 falls within that range of x values that we have actual data points for. So in the language of statisticians, this is called interpolation. So when we are within our data set, when the x value we're going to approximate using our regression line, and it's within our the lowest x value and the largest x value, that's called interpolation. Well, what's really cool is we can do this on our calculator because we have this line, this regression line is stored into y1. So if you hit y1, or just hit y equals rather, you'll see it's the calculator already copied it in there for us. That's when we put that y1 over there when we said store the regression line. So now I'm going to go to the home screen. So that's without the graphing, without this. I'm going to go second, and right next to that is mode. So that quits the screen we're in and goes to the home screen. Now we can go using functional notation. The calculator understands. I'm going to go y1 of 5. So I'm going to go back to y1. So that's again variables, right arrow, enter, enter, and that's going to copy a y1 onto the home screen. Tell me if I'm going too fast. Okay, variables, right arrow, enter, enter. I'm going to go a left parentheses, which is right above the 8. I'm going to put in the number 5 because that's where we're evaluating that. I'm going to put a closed parentheses above the 9. And now the calculator understands that, taking our equation with all the decimal places of accuracy that's copied into y1 and evaluating it at 5. And then we'll write that to 3 decimal places, so it looks like 4.966. And so that's interpolation. Does that make sense?
Could we just use the table?
Yeah, as long as it works out to get the right values.
Oh.
But if you pick something that's not one of those values on the table, then
Yeah.
you know, if I said what's f of 3.617, you're in trouble.
Yeah.
Okay, so now we're going to go f of 10. So now 10 is outside our data set because the biggest x value we have is 8. So in the language of statisticians, this is known as extrapolation. Interpolation when you're within the data set, extrapolation when you're trying to kind of predict what's going to happen outside the data set. And this is generally frowned upon by statisticians because we're assuming that the conditions that led to these data points are going to continue outside there, but we don't really have evidence of that. So you can get yourself in trouble sometimes doing this. But we're not worried about that because we're not statisticians anyway. We're going to do it again, and we're going to go y1 of 10. Variables, right arrow, enter, enter, parentheses, 10, end parentheses, enter. Oh, we're going to get down like it's second nature. So that's 15.644. 15.644. 0.644. Okay, so far, good to go? Anybody not getting that? Now, we said that it looked like a good line of fit to us when we graphed it. Well, statisticians have a better way, maybe a more scientific way of deciding whether it's a line of good fit or not, and that's known as the R value. And so the R value is going to be between -1 and 1. And an R value that is close to either 1 or -1 is considered a good fit. That means that line really is modeling, matching the data well. You can have confidence in it that it's a good representation of that.
What's the after plus and minus one?
Oh, come on now. Are you challenged to learn to read my handwriting? Okay? An R value close to 0 means it's a bad fit. So that, and I'll try to give you some examples of this in a minute after we're done with the calculator. So an R value close to 0 means either the line that we've got isn't matching that, it's not the right line for that data, or what usually happens, because we entered all this in, is the data that we're looking at isn't really linear. It might be some other curve, or it might be just random stuff, but it isn't following a line well at all, and maybe we should look at some other plan. Okay, so let's see how we can find the R value on our calculator there. So we are going to, I don't do this very often, so we're going to go back to Stat, and then we're going to right arrow to Test, so click over twice, and we're going to look for what's called the linear regression t-test. So it's going to be down a little ways here. Linear regression t-test. There it is. So it looks like EF. It looks like F is the linear regression t-test. You okay with that? So we're going to hit enter. And it's going to ask us for, we've got the X and Y list in the right place. We don't have to worry about frequency or whatever that other stuff is. You probably don't have anything in the regression equation. So this is there from first hour. So you need to put in Y1. So remember, you're going to go variables, right arrow, enter, enter, and that'll copy Y1 in there. You with me? Any nods or heads? Okay, then I'm going to down arrow and just hit calculate and then enter. And it does its magic. It does all the work. And now we've got to go scroll down until we can find the R value. So there's lots of other stuff in here. We're not really using that. There's R squared, and below that is R. So the R value here is 0.987. That is really close to 1. So that means that is a very good line of fit, and it is a good estimator of what's going on there. Okay? So I'm going to stop this video, and I'm hoping that it's actually still running.